Yeah, we're looking for waves. They carry energy away from the source. Oh, there's one. On the ground, wave. Get on the ground. Is that energy?
No.
Is that your energy?
I've never seen it before.
That's what they all say. Hi, I'm Eric.
And I'm Ankit, and today we're going to teach you about waves.
Waves are the transfer of energy through a medium, which include light waves and sound waves.
And even heat waves and ocean waves.
For example, we're going to show you with this piece of string.
I'm going to add energy to the string by plucking it.
And the energy is being transferred in the form of waves.
Okay, so a wave is made up of different parts, and this is a wave. The top part of the wave is called the crest. And then from crest to crest, the distance is called the wavelength.
Frequency is the amount of crests that go by in a wave in a given amount of time. And say this board is 1 second. And so this wave would have 1, 2, 3 crests in a second, which gives it a frequency of 3.
Okay, so even though all these waves are light waves, some of them are longer and some of them are shorter, so they're not all the same. Radio waves, microwaves, and infrared waves are long waves, which means they have a longer wavelength, and this means that they have a lower frequency and a lower energy, while ultraviolet waves, X-rays, and gamma rays are all short waves, which means that they have a shorter wavelength and a higher frequency and a higher energy. Okay, so even though all those waves are light waves, some of them are shorter and some of them are longer. Like radio waves, microwaves, and infrared waves all have a longer wavelength, which means they're longer. And ultraviolet waves, X-rays, and gamma rays all have a shorter wavelength, which means they're shorter.
Wavelength and frequency are inversely related, which means as a wave gets bigger, it has bigger wavelengths, but it means it has a lower frequency. And so, as this wave is bigger, there's less times the crests go by as it would a shorter wave, which in the same time period has about double the wavelengths that go by. Wavelength and frequency are inversely related, but energy and frequency are directly related, which means the frequency of a wave increases along with the energy of the wave. And so a low wave with a low frequency has a low energy, but a short wave with a high frequency has a lot more wavelengths that pass by, so it has a higher energy. Now on to the fun part. We get into the problems, but you need to know before, wavelengths are measured in meters, the frequencies are measured in hertz, and the speed of a wave is measured in meters per second.
I have a question.
Yes, Ankit.
Violet light has a wavelength of 4.1 times 10 to the negative 12 meters. What's the frequency?
That's a great question, Ankit. Okay, well we have this circle, so if you're trying to find the speed, you cover the speed, and it's whatever the frequency times the wavelength is. If you're trying to find the frequency, you take the speed, which is always going to be 3.0 times 10 to the 8th, and you divide it by the wavelength. And then if you're trying to find the wavelength, you take the speed, which is 3.0 times 10 to the 8th, and divide it by the frequency of the wave.
Somebody else needs this one,
And so
I can use this one.
in your question, it says violet light has a wavelength of 4.10 times 10 to the negative 12, and you're trying to find the frequency. You cover the frequency, and we know that the speed is going to be 3.0 times 10 to the 8th. So we take that. So this is a speed, and we're going to divide it by the wavelength. And it says here, the wavelength is 4.10 times 10 to the negative 12, which will then, it'll give us our frequency.
Okay. So now, you just gotta add like 2 minutes.
So, let me plug that. It is 3.0 times 10 to the 8th divided by 4.10,
That was terrifying.
which then gives you a wave. The
Okay, so
frequency
let's just start
is 7.32 hertz. Does that answer your question?
Yeah, I think it does.
Yeah.
Wait, I have another question.
Yes, Ankit.
Green light has a frequency of 6.01 times 10 to the 14th hertz. What's the wavelength?
That's another great question, Ankit. Okay, green light has a frequency of 6.01 times 10 to the 14th hertz. What is the wavelength? So we're trying to find the wavelength. So we're going to take the speed, which is 3.0 times 10 to the 8th, and we're going to divide it by the frequency, which it says here is 6.01 times 10 to the 14th hertz, which will give us our wavelength. So, we go to the calculator, put in the speed, and divide it by the frequency, which gives us 4.99 times 10 to the negative 7th meters for this wave's wavelength. I have a question.
Yeah.
What's Planck's constant?
Well, Planck's constant is a value that you use to calculate the energy from a photon if you have the frequency, and it is 6.626 times 10 to the negative 34th joules per second.
So, how would I calculate the energy of a photon of radiation with a frequency of 8.5 times 10 to the 14th hertz?
That's easy. All you have to do is cover up energy, and then you multiply Planck constant by the frequency that you have. So that's 6.626 times 10 to the negative 34th joules per second times a photon whose frequency is 5.02 times 10 to the 20th hertz. And when you multiply that, you get the energy of the photon is equal to 3.326 times 10 to the negative 13 joules.
Thank you. Now I know how to do wave problems.
Thanks
Thank-
for watching our video.
Hope you learned something about waves.